Thank you, CC. Thank you. How are you today? Good, good. Now we talked about CRC. We talked about parity bit error detection system. Today, I'm going to be talking about Hamming code. Something wrong there? Tell me when it's fixed, if it ever gets fixed. I want to reverse the. Yeah. Okay. Right. Hamming code. Let's look at Hamming code is similar to parity error detection system, but it works a lot better. So the idea is you can break your message into groups. You might be able to pick each group individual, and then it will give us extra power to find out the errors from the rest. So let's see how it works. Imagine that we split our data into three areas. Area A, Area B, and Area C. And as you can see, there's intersection and there's union here between the different areas. And let's imagine if we have some data that we want to work out. For example, 1101. Let's say this is the message we want to send. Now, the way Hamming code divides it, splits it into separate areas, and then if an error happens that affects two areas, it knows which bit it can actually pinpoint the bit. So imagine that's the data. So let's turn the mobiles off, and let's fill in the data. Let's say that's data number one goes there. That's the other one. And let's forget about the last one, just zero. So let's say we have three pieces of data. Now we need to fill in the parity. So in Hamming code says treat no. Let me put the data in a different place. Let me put the data here. 1, 1, 0, and 1, and 1 there. Is that the way it works? I think that's better. Okay, and I'm going to use a different color for the parity bits. Make it much easier. Yeah, the data goes in there. That's first I better make sure that I'm actually sharing that on. It wasn't being shared, so that wasn't the. Stop sharing and share again. I think it is. It's being shared now. No, there's something wrong. Reversing this camera? No. Yeah. Okay. I hope this is the way it should be. All right. Again, sorry, we're going to start again. Imagine data is divided into a number of areas. And let's take this data that we want to use, for example, 1101. So what we do is fill the data in those areas, let's say 1, 1, 0, and 1. This is our data. The point is that this area A, area B, and area C, so we split our data, we put certain bits in area A, certain bits in area B, and certain bits in area C. And now we're going to start using the parity. Remember, this data is normally just in one frame, but we identify which bits. So that bit here, bit number 1 goes in there, bit number 2 goes in there, bit number 3 is there, and so on. And this is bit number 4. But now let's look at every group of bits that fall in one area independently. And let's see if we can work out parity system for them. And like every parity system, it can be an odd or even. So this is Hamming code error detection correction. So let's look at area A, just A, forget about B and C. And we look, and area A here has the 3 bits, 1, 1, that one, and that one. So they share area A. Now, we want to add a parity bit in area A with those 3 bits in such a way that we're going to have, for example, odd or even. And let's pick even now, for example. That means area A must have an even number of bits that have the value 1. So what parity bit should we add? We need to add a bit, either a 0 or a 1 in area A. What value do you think the bits we should add, a 0 or a 1, in order to have an even number of bits that have the value 1 in this area A? Obviously, they're 1, 2, 3. That's an odd number, so we better add 1 to make them even. All right, so now let's do it for area B. 1, 2. B already has 2 bits that have the value 1. That's even. So we're going to add another parity. Should we add a 0 or a 1? A 0, to make sure that B also contains an even number of bits. I'm just going to remove other stuff to make it less complicated. All right, and then now area C. Looking at area C, any idea? What do you think? Area C has, how many bits does it have that have the value 1? It has 2 bits, and therefore we add a parity bit 0. So that's how Hamming code starts. The sender will split the data in the frame into groups, and each group is independent, but they intersect together. But just looking at each group independently, and add a parity bit for each group. How does that really work? Okay, let's say when we send, of course, we'll send the parity bits with the data. So let's say we sent this whole thing as a frame, and one of the bits changed. Okay, so this is what the receiver does. Maybe no change has happened. So when the receiver receives this frame, it looks at every area and says, okay, let me count this one. 1, 2, 3, 4. That's perfect. It's even. I'll remove this parity bit and just take my data. And look at this part, this area. It's 1, 2. That's an even number. That's great. No error. Get rid of that parity bit. And then look at the last group and say, oh, 1, 2, that's even. That's perfect. There's nothing gone wrong. Get rid of those parity bits and just lay down the data. That's how we check it if there's no errors. Let's imagine there are an error. Let's say, for some reason, let's say this one turned into a 0 by mistake. So due to communication. The sender put 1, but when we transmitted it, the receiver received a 0 there. Wrong frame, one of the bits flipped. So now, let's check group C. The receiver will check all the groups. So group C counts 1, 2, it has 2, that's even, there's nothing wrong with group C. It'll look at group B, for example, say, oh, well, there's only 1 bit, that's an odd number. There's something wrong with group B. Let's check group A. 1, 2, 3. That's another odd number. That's wrong. So now we have 2 groups with errors. 1 group has no error. So the question becomes, what are the 2 groups that intersect? Which bit is part of group A and group B and not part of group C? So looking at this one, you can actually tell that group A and B, they intersect in 0 and 1. But group C is part of group 1, so that's not on, and that leaves us with that bit there. So we can actually identify which bit has the error. So all the receiver has to do is just change this to 1 and checks again and finds everything is perfect. All right? Well, which is good and easy to do. So I'm going to do it one more time with an error. Same thing, Hamming code. And using an even parity, and we're sending the same data 1, 1, 0, 1, and there are 3 groups A, B, and C. The sender sent 1, 1, 0, and 1. That's data 1, data 2, data 3, data 4, and also put in the parities 0 and 0. Now, okay, I want you to look away for a second. I'm gonna pick it, yeah?
So the way you enter the bits like data 1, data 2, data 3, data 4, that's standard? Or like?
No, this is just to get you the idea. Later on, we'll find out exactly where in the frame there does data 1 fall, which bits in a frame. A frame may have 100 bits or 1,000 bits. Which bits are group 1, which bits are group B, group C, and all that. Okay, so we get to that. But once you understand this idea, that's it. The rest of it is simple. So now, I'm going to flip one of these bits without you knowing. I want you to go through the process and tell me which bit is gone flipped. The process again is simple. You go in group A, you search. That's odd. We are working with even. Oh, then A has a problem. Look at this one. Count B. 1, 2. That's wrong there. Let's go group C. 1. That's odd. That's something wrong. So whatever the bit that has the wrong is something that's part of A and B, but it's not part of A and C, but it's not part of B. So it's part of this group and that group, which is they intersect in these two bits, but not be part of this B. This one is part of B, so we can ignore it. So we're left with this bit. Is that okay? Very simple. So I'm going to put this one back and correct it. So easy to correct. Now I'm going to have another one. This is the last example we'll have. So I'm going to flip one of these bits, and now you have to find out which bit and how did you find out. So, right. Well, which bit is now has an error? Is there an error there? So you count how many bits in group A that have the value 1. They should be even in group B and also in group C. So, go on, tell me. Group A, is it perfect?
No.
So there's an error in group A. What about group B?
No.
What do you mean, no? It has an error? Okay, so what about group?
Error.
Also error. So which bit actually is intersects, or the intersection of A, B, and C, or part of A, B, and C? Which of the bits? Which bit is actually part of A and also part of B and also part of C? This bit here in the middle. And therefore you know this is the bit with the error, and all I have to do is just fix it, flip it. If it was 0, turn it to 1. If it was 1, turn it to 0. It's a very beautiful, simple idea that this guy came up with, and it works. It works beautiful. Now, we're going to see how now it works on real data. So how do we decide, how do we, and you need to know how to do it. So for example, you might be given a problem, you might be given the data. So 1 1 0 1 1 0 2 4 6 1, for example. This is our data we want to send, and we want you to prepare a frame and send it as a sender. Now, what you need to do is prepare a frame like this, and I'm going to number them. So it's always good to have it in a table. And I'm just going to put a sequence number on all these columns. So this is position 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whatever. You know, we keep going as big as the frame will take. Now, these are things you need to notice. Which bits, where are the parity bits going to go? And the parity bits are going to go as follows. Bit number 1 is going to be a parity bit. And then number 2, and then number 4, and then 8, 16, 32, and so on. So we start with number 1, that's parity bit, and we call it parity bit number 1. This one is parity bit number 2. Now this is where the data goes. This one is position 4 is always a parity, never put data in. And the next position is 8, and so on. And we call them by their names. We call them P1, P2, P4, P8. So we know this is parity, just for us simplicity. So this is the parity bit number 2. We know where its position is. Now we fill in the data in the rest of the information. So here's now I'm going to send, this is my frame here. I put nothing there now, nothing there now, nothing there in the parity bits until we work out what value goes in there. Let's just fill in the data. So the data is going to go there. That's 1, 0, 1, put nothing here, 1, 0, 1. So that's my frame is going to go. All the data is put there. Parity 1, 2, 4, and 8 are reserved for the parity bits. Now all we have to do, find out what value should we put in parity 1. And in order to do that, we need to figure out which of these bits represent the group P1 that goes into with group P1. And it's simple. And there's a simple rule. For each bit parity. For each parity, bits, yeah, I'll just have n. It could be parity bit 1, parity bit 2, 4, or 8. What other bits that go with it? Start at n, take n bits, use or take n bits, and skip n bits. What does that mean? Okay. For parity 1, start at number 1, use 1 and skip 1, and keep doing that. Use 1, skip 1 until the end of the frame. Right, so the group that goes with parity 1, I'm just going to list now parity 1 here. Bits. This one, because it's parity 1, it says start with your n. So now we're starting with parity number 1. That means we're going to start with this one and then use it. We're going to use this one and skip this one and take this one and skip number 4 and take number 5 and skip number 6 and take number 7, skip number 8, 9, skip this and this. So these are the bits that go into parity 1. This one here, that one there, this bit and that bit, they're all 1 for some odd reason. Okay, so this is the group A that goes with parity bit 1. Understand that? So once we have decided which bits go with parity 1, now we can count them and we see what value should parity 1 have. So parity 1 now is in a group with those. So you count 1, 2, 3, 4, 5. It's odd, then we have to give it. So there are 5, which is odd, which means add 1 to it. So this has to go 1. Parity 1 has to be 1 to make them 6. That's what the sender does. Okay, now if you understand this, let's go to and work on parity number 2. That's why, guys, it's nice, easier to have a table, have columns and number them. Some people, they say, okay, no, I don't need to number them. I just put here 1, 2, 4 and pick the bits, you put them there. It gets a little bit kind of messy. Sometimes you make a silly mistake. You know how to do it, but you just put something in the wrong column or you get the wrong count. Now, parity number 2. Anybody can follow this rule that says for parity number 2, start at number 2, take that 2, take 2 bits, and then follow and skip 2 bits. So instead of 1 now, we're just going to do the same thing, but we're going to work on 2, number 2. So it's start number 2. So you forget about the first column. You don't go near. You start for bit number 2, start at number 2. Okay, we're going to start at this point. Use 2 bits. So we're going to use 2 and 3. So position 2 and 3, and we're going to skip 2, which is 4 and 5, and we take 6 and 7, right? And then skip 8 and 9, and take 10 and 11. So these are the bits that are associated with parity number 2. You'll need to do it now. I'll give you a quick example, and you'll have to work this out. So make sure, you know, you're following what I'm saying here. So parity number 2 consists of these 2 bits, 2 and 3. We're going to skip 4 and 5, 6 and 7, skip 8 and 9, 10 and 11. So let's fill in the information. So bit number 2, parity bit number 2, we don't know what value it is. Number 3, we already have it. It's data. It has the value 1. 4 and 5, we skip. 6 and 7 are 0 and 1. There. We skip parity 8 and 9. And we go those with 2 positions. So this is the second group, parity 2 group. So how many, now we can count how many bits does it have and what value shall we put for the parity. We count them, there are 3. That's odd. We better make them even by adding another one here. Sorry. Yeah, sometimes I make a mistake intentionally and see if you're following me then. Right, so this is the correct one. And now, okay, we had actually 3, and therefore they are an odd number, and therefore we're gonna add this extra parity bit as 1. So that's the new parity bit we added, that's the parity bit we added, parity bit 1, parity bit 2. Now it's gonna help me with parity bit 4. We start at number 4, we use 4 and skip 4, use 4 and keep going until you get to the end of the data. So you're smiling. So tell me, maybe help me here. Where shall I go here with parity 4? See, the thing says start at number 4, right? So you go straight to number 4. That's number 4. We're in column 4, start with column 4. So we go there and use those 4, 1, 2, 3, 4. And then we're gonna skip 1, 2, 3, 4 and take any more. There's nothing else, so we stop at that point. So let's fill this. We don't know what parity 4 is, but we have 5, 6, and 7. They're already data, 1, 0, 1. And that's E2, which is an even number, which we should add a 0. So this bit 4 should be a 0. All right? Everybody's happy with this? Right, so the next one. What's the next bit? The parity 8. So now parity bit number 8. And we start at number 8. So we go straight to this one. The mistake some students start, they start here. And they start counting 8. Or with number 4, they start here and they start counting 4. No, make sure you go to that column and start from that column. So we start, for parity bit number 8, we go to number 8, we start at number 8, we take 8 bits, and then skip 8 bits until we reach the end of the frame. We can't even get 8, there's less than 8, but we'll take 8, 9, 10, 11, and if there was more data, we'll take up until 16, where parity bit 16 starts at that point. Okay, so with this one, the data is 101. Right? And because these are 2, then this parity should go as 0. Now, how do we send this frame? That's it. Now we send, this is our frame, we send it. Here's the original frame. All we have to do is put in the correct parity. This is 1 there, that's 1, that's a 0, and that's a 0, and that's the frame gone. With 4 groups in this particular example. Okay, so maybe part of the question, and it's almost a definite question, there'll be a question about Hamming code in your final exam, so make sure you know how to do it. As a sender or as a receiver. Same as CRC, you're gonna get a Hamming code or a CRC question, and maybe the 2 of them. And they're the easiest part of the exam, because you know it carries a high mark, and you should know how to do it. No 2 ways of doing it. There's one way, only the right way. And the right way gets you the full mark. Make sure you don't lose it or miss it. Right, so now, the part of the question says, okay, give me the final frame to be sent. That includes the parity bits. So I'm just gonna look at them. The first parity is 1, the next one is 1, the next column 3 is already 1, that belongs to data. And this one is a 0, that's parity 4. I'll just mark the red ones, the parity, but you don't have to, just for now to understand which ones are the parity ones. These are the parity bits in red. The rest of them are the normal data, 1, 0, 1, 1, 0, 1. And this is the frame. Let's reduce the zoom or whatever it is. Yeah, sorry. Okay, is this clear enough? Easy enough? Let's see what the receiver do in order to work out. Is there an error in this or not? This is what the sender does. But don't forget, this is the sender.
Can you please repeat again
Yeah. So you'll be doing an example. We'll do another example. It's easier than going over the same material, I think. But okay, just a quick run. You're given some data. You say, okay, we want to send this data.
No, just only the result.
Okay, let me go through it. So first, you spread the data into the right columns. Why? Which columns do you leave free? P1, P2, P4, P8. That's column 1, 2, 4, and 8. And fill the data in the rest of them. So that one goes there, the next one goes there, the first available column. Don't write anything in the parity column. Now, all you need to do now, work out what value you get for parity 1. In order to do that, later on you'll be able to do it on the same frame. Pop, 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 just skip 1. But for now, just to do it so you know the technique. With parity 1, start at column 1. These are the bits involved in parity 1. You start at 1, take it, use it, skip 1 and take the next one, just 1, skip 1 and take 1. So you're going to take this one, skip this and take this one, skip the next one, which is 0, and take the next one, number 7, skip number 8 and take 9, and skip number 10 and take 11. You keep doing that for the parity 1. Once you have the correct bits here, you count them. If we had said, hey, we want an even number, even Hamming code, well, then you have to make sure that the number is even. If they're odd, add 1 to it to make it even. If the question will say, hey, we're using odd Hamming code, well, then make sure they're odd. If they're even, add a 1 if it's, but you're always adding a 1 or a 0 in parity 1. Then you go to parity 2. You start at number 2, column 2, take 2 columns, 2 and 3, and skip 4 and 5. Take 6 and 7, skip 8 and 9. Why 8 and 9? Because now we're working on parity 2. You take 2 and skip 2, take 2 and skip 2. And do the same thing. Now, when you get to parity 4, you must start at column 4 and take 4 columns, 1, 2, 3, 4. That's 4, 5, 6, and 7. And skip 4. That's 8, 9, 10, and 11, and so on. And same with parity 8. You start at number 8, you take 8 bits. If there are not 8 bits, take as many as there are. And okay, so when you finish, you've worked out the parity bits. Now you rewrite the whole column that we've written up at the top without parity bits. Just write it again, but now this time we know what the parity bits are. Parity bit 1 is 1, parity 2 is 1, parity 4 is 0, and fill in the rest of the data, and this is the frame to send. Yeah?
So when we start at parity 2, for example, we take the parity 2 bit as the user is empty, right?
Yeah. Yeah.
So you always treat it as
start at that point.
Yeah.
Start at column number 2. Yeah.
And we always treat it as 0 regardless if it's even or odd.
Yeah, regardless whether it's 1 or 0, it goes into the count for the bits that share parity number 2. Now, I'm going to write this same information frame. So this is the question you get now.
Sir, it is possible to get different 1 and 0 in the same column. Like 1 and 0 in the same column.
No, 1 or 0. If you do that, you might get an error. All right. Yeah?
If it's 1 is the one, the top one, then it's 4.
I don't know. This is the technique. It works out beautiful. 2's power, the powers of 2 seems to give a nice. You can research it if you like. You can have a project at the end and try to find what's wrong with it or improvements or whatever you feel. But let's now go as a receiver. Now here's the question. The question is very simple. You're told a sender has sent you a frame. The sender has used Hamming code and has sent you this frame. You've just received it. Does it contain any errors or not? So you count how many, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. My suggestion, my You don't have to do it, but it makes life easy for you. Make a table of 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And number them. Let me get in the back pens. Every pen Anybody got a black pen, please, guys? I got it. I have it. Yeah. No, I have blue. It's okay. See if it's any. The color is okay. 1. Just number them clearly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and fill the information. So this is 1, 1, 1, 0, 1. Follow me if I make a mistake, please. 0, 1, 0, 1, and another 0, 1, and another 0, 1. That's simple, isn't it? So that's the frame received. Now, let's just pull down the parity one. Eventually, you'll be able to do it without having to pull down. Now, who's going to read me all the bits involved in parity one? Are you okay in the corner there? Just give me the column position. What column position are grouped with parity one? I can't hear. No. Start. What columns make up the group with parity one? Okay, so this is the song you should learn or remember. For parity one, start at 1, take 1 and skip 1, take 1 and skip 1. If it's 2, you start at 2, take 2 and skip 2, and so on. So at number 1, we start at number 1, take this one, right, and then skip number 2, yeah, go to number 3 and write it down, yeah. Okay, just give me the numbers now. 7. Okay. This simple. 1, 3, 5, 7, 9, and you keep going. This is group A. But now we call the group parity 1 group. Right. How many bits are there? They should be even. They'll tell you the sender have made an even parity Hamming code system. 1, 2, 3, 4, 5, 6. That's perfect. Okay. Out there, somebody at the very end there. Can you help me with the parity? Which columns will I take? Just call me the column grade there. For parity number 2. If you forget the song, here's my song. For number 2, start at 2. Take 2 and skip 2. Take 2 and skip 2. Go on. So what columns will I take now? 2 and 3. Thank you. And then? You start at 2, take 2. Take the 2 of them, 2 and 3. And then skip 4 and 5 and take 6 and 7. Good. And then skip 8 and 9 and take 10 and 11. That's how you get parity 2, right? Right, is there an error in this group? 1, 2, 3, 4. It has 4. They should be even, and they are even, and they are perfect. All right. I have another volunteer here. Yeah? What columns should I go for parity 4? 4, 5, 6, 7. And skip 8, 9, 10, 11. And if there was 12, 13, we'll take them. If not, we'll stop. Right. Is there an error here? No. There are 2 bits that have the value 1, and there is no error. Now, who's going to help with parity 8? Yeah?
8, 9, 10, 11.
8, 9, 10, 11.
8, 4,
and no problem. So there are no errors in anything. That's great. Okay, this is, I don't think probably in an exam ever we gave students who said, okay, check there's an error, and there was no error. But that's good. Now, extract the data. Get rid of the parity bits and just give me the pure data. That's what the receiving machine should do. it uses the parity bits to check for errors. If there are no errors, get rid of the parity and just give me the user data. So who's gonna help me here? Just, yeah, go on. What data, what's the data we're taking? Do you want to tell me which columns and I copy them, or you want to read me the sequence? Nope. I'll write one, yeah? 1101, yeah? Okay, what's the idea? Where is the data? How are you going to find out where the data is? All you have to do, get rid of the parity bits. That's number 1, number 2, 4, and 8. Get rid of them. And just read the rest of the data. So it's 1101, 101. That's the original data that the sender has sent. How did we get them? Just get rid of the parity and just read the rest of the frame. Okay, is everybody okay with this? No problem? Okay with it? Okay, good. It's just, I can tell with some people they are okay, they're happy. With some people, their face doesn't change. Whether they're happy, they look like this. They're sad, they look like this. It's always the same look, which is okay as well. But now we're gonna have the same frame, right? 1, 1, 1. Here it is. But now, without you looking, I'm gonna flip one of the bits, right? And we try and find out which one it is. One. Okay, one of the bits. Zero, 1, 0, 1. Yeah. Now, here's the question again. Same question. The sender sent you this frame after performing Hamming code, even Hamming code. So they did the same. They put parity bits and they sent you the frame. Now, does it have any problems? So first thing, I'm gonna just create the columns 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so maybe it's a good idea to use those square pages with square. In this one, the sender made sure every group has an even number of bits. No, we odd, whatever the sender did. Whatever the sender and receiver agree, they agree on even parity, then everything must have an even number.
We can take the both even, like even or odd.
Yeah, if we both agree, then we must stick to the same value. If we agree on even, we both must agree on even and continue. If we both agree on odd, we can use it. It's the same. All right, so we're gonna have 4 groups. Parity 1 group, parity 2 group, parity 4, and don't say parity 3 and parity 4. No, parity 4 and parity 8. Now, okay, who's gonna give me the bits for parity 1? Just let me just number them here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So tell me which. Oh, okay, we should have put them right. We should have lined them up correctly. Maybe I should have put P1 here, 2 here, 4 here, and P8 here. And this one is just the original frame. So let me put the bits in the right place. 1, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1. Right, now we have them lined up. Okay, parity 1. Which column should I go for? What's the next one? Just give me the column order. 3, okay. 5, 7, 9, 11. Good. How many bits are now in this group? 5. Is that good? No. There's an error in parity 1. Right. Let's go for number 2. Elton. That's the only name I know, guys, in this class. I don't know why. Elton John. Go on.
2, 3,
Columns 2 and 3.
6, 7.
We skip 4 and 5, so it's 6 and 7. That's 0, 0. 8 and 9. 10, 11. And how many bits are there? 3. Oh, that's another issue, right? Who else is going to help me here? Will you do it? Yeah? Parity 4. Which column will I start with? 4. Oh, very good. Okay, and then?
5, 6, 7.
And then? That's it. We skip 8, 9, 10, 11. And there's only 1 bit here, and that's also odd. This is really strange. Right. Anybody in that side? Yeah, near the window? The one, yeah. Go on, yeah. 8, 9, 10, 11. And how many bits are there?
2.
Is that okay? Or is there an error in this group? No error. So, guys, we have error in group 1 plus group P2 plus P4. You just write the positions, the actual numbers of the parity bits, and add them up. 1 plus 2 is 3 plus 4 is 7, and just tells you, this tells you bit number 7 has a problem. That's why they use the binary system. So this column, this bit, and in fact that's the bit I changed without telling you, you know. But if you check, this is the one, the original number we had earlier, the frame. That's 1 1 1 0 1 0, and that should be a 1, you know. But that's the one I flipped. So now, this is what you get in the exam. You know, you've decided, like you get a mark for this, for the first one, a mark for the second one, getting the correct number, and then a mark for identifying the correct column bit, which bit has the error. Now you have to remove it, correct it, and then get rid of the parity bits to get the final mark. So I'm gonna rewrite the numbers here, but just correct the 7th bit. So one here is gonna be a 1. The rest of them are the same. 1 1 1 0 1 0, and that's the one we changed. 0 1 0 1. Now get rid of the parity bits. What are called the parity bits? What columns are the parity bits? No, without looking. Where are the parity bits? Which columns there are in? I'm going to get rid of them. Here's the frame received, but I want to get rid of the parity bits. I only have the data. Which ones will I get rid of? Yeah? Column 1 is gone, right? What else? And 2, hurry up. And 4, 1, 2, 3, 4. This one is gone, this will go. So I'm going to take that one and 8. So 8 as well, this one is gone. So that one, number 4, and number 8. So the data that's left, 1, 1, 0, 1, 1, 0, 1. That's the original user data. After getting rid of that parity bits. Yeah?
I couldn't get the idea. First of all, we calculating input or create the providing the code because we are editing bits. And then transferring, and then you see what the import to that.
Every error system or every system routing everything. When they're sending the data, you have to send more data. Okay. To be used. So once we finish with it, we throw it away. The user doesn't want it. You should not change the user data. It's already good for but in between, Just enough for suitability for this one for error detection to make sure everything is done okay. So this is part of the cost of every system, and the cost is very little here, very quite small cost, because the next bit is going to be bit number 16, the next bit is number 32, the next bit is 64, and so on. So the number of bits is reasonably small, but still CRC is probably as good as well. Yeah.
What happens in 2 bits?
Oh, okay, that's another question. I'll get to it once we master this. Yeah.
First you said like we can add 0 or 1 to make them even.
Yeah. You must.
Why we didn't add 1 or 0?
No, we are acting as a receiver here. We are a receiver. See, if you are a sender, you have to add the bits. The receiver has to use the bits that were added, and then finally get rid of it. Okay, so you have to be careful, guys. Sometimes I ask a question, say you are a receiver. Can you do what the receiver does? And the students start doing what the sender is doing. You're doing something not what the question is asking. Maybe you're doing it correctly, but it's not what the question wants. And you get a 0. So be careful. When you read questions, guys, in the exams, my advice, highlight or underline the key words in every question. You read a question, every question has key words. In this kind of question, sender or receiver, make sure you get the word even or odd. Sometimes, the question says, here it is, give us an odd Hamming code. And you start working on even. You do it perfectly on even, but that's not what the question really asks. So be careful. Make sure you read the questions, very, very kind of quietly, and my advice, highlight the keywords so you don't forget them, or do whatever you feel is best. Okay, now let me see if you can work this out. 1 1 1 0 0 6. Yeah, just 1. Okay, we're going to send this. Use Hamming code. Please use Hamming code, even Hamming code, as a sender. You are the sender. You want to send this data. Please give me the final frame to send. So, start going about it. First thing, create this table of 11 or more columns. Remember, I gave you 7 because I know we're going to add 4 bits. They're going to be a total of 11 altogether. If I gave you another one, then you have to go up higher to maybe to the 16. So do it quick on a piece of paper. Give you a piece of paper. Anybody needs a piece of paper? I have one. I have 2 pieces of paper. So first thing, create a table of 11 or 12 columns with maybe 5 or 6 rows. Anybody needs a paper? Come on, quick guys, don't waste time. Get used to the idea of drawing a table, it's easier. Take my advice, because not for me. I'd read any answer you put, but it's very difficult to follow it without the table. Yeah. You finished? Okay. Because you're going to add, you're a sender, you're going to add 4 more bits. So that's why I said have a table of 11. First decide, don't put the data there yet. Decide where's the position for the parity. Which columns will be considered parity. So have a bigger table like this, and you have to decide, okay, this column here is parity. 1, 2, 4, and 1. Fill in the data in between, outside the parity. Okay, and then start counting to find out what the parity system is. Remember, the sender has no parity bits. He's going to create parity and calculate parity bits. So first, create a table of at least 11 or 12 columns, then decide which columns are going to be the parity columns. Do you know what columns are the parity columns? Tell me. Thank you. Anybody has problem starting? Who has not started yet? Take the Hey guys, a lot of people, give me a second, thank you. A lot of started the wrong way. I'll just show you how to start and let you finish. Maybe you've already started correctly. Just stay quiet for a second. I said make a table 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and so on. So I'm going to number them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to write the data here that I have. And then I'm going to work out what's for parity 1. Right, when you write this data, where do you write it? Remember, there are 4 columns you should not be writing in. This is here a parity column. The parity columns are 1, 2, 4, and 8. Don't write anything there. You're a sender. You're to find out what these values are. You're not given those values. So where do you put the data? You put them in the next available column. So this bit 1 goes in column 3. The next bit here goes in 5. The next bit 6. The next bit is 7. 8, you can't write nothing in 8. So that 0 goes in there. And then 1 here and 1 there. So that's how you start. You start, you don't know what parity 1, 2, 4, or 8 are. You don't have them. You are the sender. You're going to create them. Now, find out and put it there now, the parity 1, based on the group of bits that go with it. So which group of bits go with parity 1? It's 1, 3, 5, 7, 9, and 11. And that's how now you can figure out what parity 1 is, based on the number of ones in this group. And then you do the same thing with parity number 2. What bits parity number 2, and that tells you where parity 2 is. So it's finished. So that's the same error. Yeah. Start again. Column 2, 4, 8. I want from the data. You're a sender. I just gave you this data. But you can send this data. You put the data in the parity place. Wrong. Leave the parity columns free. Okay. Right? See, when you start first, say, okay, as a sender, you say, column 1, I can't put nothing in. Column 2, 4, and 8. Just mark them up, block them. I can't use them. So, you're going to start with your data. Where's the first available place? This one, column 3. Put 1 here. The next bit, you can't put in number 4. You put number 5, 6, 7. You can't put anything on this 8, 10, 9, 10, 11. Okay, so this is now how you start. Your data is put in the right place. Don't put nothing in the parity bits. Now you're going to find out what value is this parity bit going to be. Well, how do you find it? You have to find the group that's associated with it. So that's position 1, 3, 5, 7, 9, 11. You count them. 1, 2, 3, they're odd. Then this one has to be a 1 to make them even. Now, parity number 2, you go to 2, 3. That's the odd one goes there. Skip 4 and 5. You take those 2 here. Skip those, take those, and count and find out what the parity 2 is. Okay. Anybody's having issues or problems? You should show me this in the exam. I don't want to see this. I don't want to see this. 1, 2, 3, 4. Okay, starting with the and then start put the correct bits in the Hey guys, I'm gonna write the solution if you don't already have it. What time is it now? Do we finish? What time do we finish at? Okay, what's your question? Okay, I'm gonna do it now. Okay, we'll do it one more time. I'm gonna go through this. Anytime you get this question, first make sure you're acting as a sender, right? A sender, that means you don't have the parity bits, you're gonna add the parity bits. You are given the data, so this is data. When you put the data on the table, don't put data in the places where parity should be. So where are the parity bits? You mark them, you say, this is parity 1, this is parity 2, that's parity 4, parity 8. Don't put any data in there. Even mark them, shade them if you like. Now let's put the data there. So the frame is gonna spread like this. You take the first bit, you put it in the first available location, which is the third column. And then parity 4 will be here, so the next bit goes into position 5, 6, that goes into number 7. Nothing goes in 8 yet. The data goes into 9, 10, and 11. Right, so now we have the data in the right place, and we have spaces for that parity. We're going to fill the parity later. Now, we're going to decide what value will go into parity 1. So first, you have to create the group that's made up with, that's shared with parity 1, the parity 1 group. So the parity 1 group, parity 1, start at column 1, use it, skip 1, take that 1, skip 1 and take 1. So with parity 1, we take this, we don't know what value it is, we don't have parity yet, that's the one we're going to create as a sender. And then we skip number 2 and we take 1 column after that, that's number 3. We skip 4, we go to number 5. We skip 6 and we go take 7. We skip 8 and we take 9. Skip 10, take 11. So you write the data, bring down the data just that's shared for parity 1. And count it, 1, 2, 3. So in an exam, write it. Show me that, okay, you got 3, which is odd, and therefore you're going to add 1 to it, so maybe, and that's the one that you add is here. Now you can put the 1 here. Now we're going to find out now what's the second parity. So let's go to the next line and create the parity 2 group. Now, what are the bits that make up the parity 2 group? Column, which column?
A2, B2.
Right, so it's column 2
First one should be
and 2 and 3, right? What about 4?
just be
Skip 4 and 5,
6 and 7.
and then skip 6 and 7, yeah?
8 and 9.
Skip 8 and 9 and take 10 and 11, and that gives us 1, 2, 3, 4.
It's all
That's 4, it's even,
We
so
have
this one is going to be
0.
a 0. Okay, guys, everybody is okay with this? Make sure you practice it. It's a definite exam question. If not the sender, it's the receiver. You need to know both.
We have to follow this rule like take 1, skip 1, this one. In
If you find a better rule, follow it. You don't have to write it down. This is not a written rule. I didn't see it in any book. I just made it up to make things easy for me. If you find an easier way, do it. Yeah, it works for both. But yeah, this rule works for both. If you can work any other logic that goes well with you and it works to give the correct result, yeah, by all means. This is something I thought of and it seems to work nicely and easy to remember. Now the next one is parity 4. Okay, who's gonna help me there? Yeah, you look like somebody who wants to help, right? Okay. Okay, parity 4, where do we start? Start at what column? Okay, according to the rule, my rules, we start at 4. With parity 4, start at 4 and count 4. 4, 5, 6, 7. That's 1, 2, 3, 4. You stop at number 7. So number 5 is 1, number 6 is 1, number 7 is 0. And 4, we don't know it yet. And then we skip the next 4. 1, 2, 3, 4. And if there are more, 1 or 2 columns, take them. But there isn't now. And therefore you count how many ones? There are 2. They're even. They're already even. So we should not put a 1 here, we'll put a 0 to keep it even. Now, column 4. Okay, who's looking out through the window? Column 4 or 8. Is it parity 8? Which column shall we use? Say again. 8, 9, 10, 11. So 8, 9, 10, 11. Right, and that makes it 2, and that's another even, and that's another 0 goes in there. So now we've determined the 4 parity bits. All we have to do now, put them in the right place. See at the very top there. Parity 1 is 1, parity 2 is 0, 4 is 0, and 8 is 0. But we write them here, down here. So it's 1, 0, 1, 0, 1, 1, 0, 0, 0, 1, 1. And that's the frame that contains the parity bits. That's worked out by the sender as an even parity bit. All right. Now let's act as a receiver. I'm going to give you an example, almost the same. Same, but I'm going to change one of the bits and see which bit you think is right. Okay, so I'm not going to tell you which bit, but here's the question. The sender has used Hamming code, the even Hamming code, and sent you a frame. You are a receiver. Act as a receiver. So when I tell you you're a receiver, you have the bits now. The parity bits are there. So fill them in the table in the right place. And here's the frame that we receive. Is 1 0 1 0 0 1 0 0. In fact, 0 0 1 1. Now, check this frame. Does it have an error? And if there is an error, fix it. And then get just the user data. I mean, get rid of the parity bits at the end if you can fix the error. So, what you should do now, start with a table. In this case, 11 columns. You already have the parity bits. And fill the first, the 11 columns received. Mark which one is parity. And then go in each column for each parity on its own. I'm going to do the layout for you. You have to do it yourself. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is the data. This is P1, P2, P4, P8. Right, so this is just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And this is where you fill the data. That frame should go in there. I leave it to you to decide where to put it. And this is, get the group P1, P2, P4, P8. Which one is bad, which one is good? That's which one is even, and it should be even, and if it's not even. Okay, so you should have a table like that, and then you can work out where is it. Now, don't leave the columns free. You already have is the parity 1. That's parity 2. Remember, you're not the sender. If you're the sender, that means you don't know the parities and you're going to create them. Now you're a receiver. You've already received the parity. Yes? How are you doing up there? Are you okay? If you have an issue, now is the time to ask me and make sure you know. This light is not strong, is it? Can it be made any stronger? Anybody from IT that knows how to switch this thing brighter? Either go brighter or switch off completely. Who's finished? Okay. Anybody who has any problem, this is the time to. First, there's a step missing here when you flip that image. Okay, so right now we can take the entire frame you'll see, but with that just change. And then that is the only thing. Carry a mark. Keep going. Anybody finish? No? Almost? First, you take 5, 7. Three is odd. They should be even. Okay, guys. So tomorrow, is it tomorrow we meet? Then tomorrow we have another error detection system. So this system, guys, okay, the advantage of having code, it actually tells you where the error is. So now, to correct the error in to correct the error, you always ask the other side to send again. So normally we use CRC or parity, and you send me a frame and I find something wrong with it, I just discard it and ask you to send me another frame. With having code, the idea is you don't have to send it again. You just fix the bit and that's it. But it's not used. It's not used at all. And the reason it is not used, because it's only good and great with 1 bit error detection. If there's 2 or more error detection, it's more complicated and very costly. So that's for that reason it's not really used. It's only used if you know for certain your system can only have 1 error bit involved and can be detected easily, but otherwise, so you just got the idea. But maybe it'll help you one day to come up with even a better idea and your idea to work. But, right, so tomorrow, or the next lecture, we'll do the final error detection system that we need to do. Thank you very much. and good luck.